I want you to picture a bucket.
Okay.
You punch a hole in the bottom, and, naturally whatever's inside starts leaking out.
Simple physics. High pressure to low pressure.
Right. It's just how the world works. But we have a stack of papers today that are asking a question that seems to completely defy that. They're looking at the emptiest parts of our universe, these cosmic voids, and asking, is the universe leaking?
Mm-hmm.
But here's the twist that really got me. They aren't asking if stuff is leaking out. They're asking if stuff is leaking in.
And that is exactly where the bucket analogy just completely breaks down and things get really, really weird.
Welcome to the deep dive. Today we are tackling a really dense, fascinating set of documents. They outline what's called the H3OK, or S-matter framework.
Yeah.
And look, this isn't just some tweak to the standard model. It's not a new measurement of a star. This is a complete structural rethink of cosmology.
It really is. We're looking at a stack of technical papers on everything from geometric mechanics to void hydrogen, and even some really cutting-edge data from the James Webb Space Telescope.
So what's the mission today?
The mission is to understand a model that claims the universe isn't an explosion from the past. It's a continuous interaction with a higher dimension happening right now.
That is a massive claim. So let's start with that leaking concept, because that's the hook that dragged me into all this.
Sure.
The sources highlight this debate in astronomy where they're finding matter are just appearing in cosmic voids where it has absolutely no business being. The term leakage keeps popping up. Why are these authors so adamant that leakage is the wrong word?
Because words matter in physics a lot.
Lisa.
When you say leak, you imply a flow.
Mm-hmm.
You imply a fluid moving from a high-pressure tank into a low-pressure area.
Sure. Like water finding a crack in a dam.
Exactly. But the papers point out a huge problem with that image. Cosmic voids aren't low-pressure buckets waiting to be filled. They're vacuums.
Right.
They don't have walls. There is no pressure gradient pushing matter from outside the universe to the inside.
So if I'm standing in a cosmic void, all alone, I'm not seeing a stream of gas pouring in from some hole in the sky.
No, not at all. That would imply motion through space. The authors describe it as a density-conditioned state transition.
Okay, that is a mouthful. Density-conditioned state transition. Let's break that down.
So the framework posits that our 4D spacetime is embedded in a fifth-dimensional substrate. The notes call this S-energy.
Okay, so less like a sci-fi parallel universe.
Right. Think of it more like a reservoir of potential, like a background layer of potential energy and information that sits underneath our reality.
Almost like a background operating system for the universe.
Precisely. A background layer that is sensitive to density. And the core mechanic described here works in two directions. First, let's look at the exit.
Okay.
They call it critical complexity reversion.
Sounds intense.
It is. In regions of extreme density, and we're talking inside a black hole's event, horizon matter gets too complex, too dense for 4D geometry to resolve.
It runs out of pixels, so to speak.
That's a great way to put it. It effectively crashes out of our dimension. It reverts back to the fifth dimension.
So if black holes are like the universe's drain pipes, matter gets too crushed to exist here, so it just pops out the back.
In a sense, yes. They're the exit points.
Mm-hmm.
But the whole leak question is about the entrance points.
Mm-hmm.
And that happens in the voids.
Because they're empty.
Because they're simple. The voids represent a state of incredibly low resistance. So the framework argues that when the density drops below a certain threshold, that fifth-dimensional potential can spontaneously realize into 4D matter.
So it's not moving into the void from somewhere else. It's appearing in the void because the conditions are just right.
Exactly. It's a transition. Think of it like condensation on a cold window.
Oh, I like that.
The water doesn't leak through the glass from outside, right? The water vapor is already in the air, but the conditions on the surface, that temperature difference, cause it to transition from vapor to liquid right there on the pane.
That is a much better analogy. So the void is the cold window pane.
Exactly. The source material uses the phrase continuously instantiated. The void is just a low-resistance screen where this background energy can project itself as matter.
Okay, this idea of projection or instantiation, that has to change how we view expansion, because the standard story is the Big Bang, right?
It completely flips the standard story on its head.
Yeah, usually when we talk about the expanding universe, I just picture a giant explosion, boom, shrapnel flying outward. We're just debris riding that shockwave.
That is the standard bottom-up view.
Yeah.
In that model, expansion is basically just momentum. Or lately, we say it's being pushed by this mysterious dark energy.
Right.
But the H3OK framework argues that expansion isn't a result of an explosion. It argues that expansion is a structural necessity
A necessity for what?
for time itself.
Okay, you're gonna have to walk me through that one. How does expanding space create time?
Well, the papers argue that you can't have a time-directed universe, a universe where events happen in a sequence without continuously creating new volume to store those events.
Wait, really?
Expansion, it claims, is the physical manifestation of time passing.
So the universe gets bigger just because it's getting older?
In a very literal sense, according to this model, if time is flowing, space has to be growing. And this is where it loops right back to the voids. The notes call voids the engines of cosmic growth.
Okay, I would have assumed the engines were the galaxies. That's where all the action is, right? The energy, the heat, the stars.
But that's also where the resistance is.
Yeah.
The notes emphasize this efficiency rule. Dense regions like galaxies have high curvature. They're tightly bound by gravity. They're hard to add space to.
But voids are empty. Low
Yeah,
curvature.
low resistance. So when the universe needs to generate new volume to accommodate the flow of time, where does it do it? It does it where it's easiest.
Yeah.
In the voids.
This actually clears up something that always confused me. You hear astronomers say that galaxies aren't expanding, I'm not getting taller, the Earth isn't getting bigger, but the space between the galaxies is stretching.
Exactly. This framework gives a mechanical reason for that. It's not some arbitrary stretching happening everywhere. It's differential growth based on resistance. And the kicker is, if you accept this, you don't need dark energy.
That's the holy grail in cosmology right now, isn't it? Getting rid of dark energy.
It is. Because right now, dark energy is just a label for we don't know.
It's a placeholder.
It's us saying we see the universe accelerating, we have no idea why, so let's call it dark energy. This framework says you don't need a magical force pushing things apart. You just need the geometry of space growing from the fifth dimension, primarily in the voids, simply because time is moving forward.
But if this is happening, if the voids are these active engines of creation, there has to be evidence. You can't just say it's happening. We need to see the condensation on the window.
Right, and that brings us to the void hydrogen floor.
Okay, this was a specific term in the outline. What exactly is a hydrogen floor?
So, under the standard Big Bang model, voids should be, well, effectively dead. Any gas inside them is just leftover debris that hasn't fallen into a galaxy yet.
Over time, gravity should be cleaning them out.
The voids should be getting emptier and emptier as the universe ages.
Correct.
But the observational data, specifically from radio astronomy and these 21-centimeter experiments, it shows something else.
What's it show?
It shows a persistent baseline level of neutral hydrogen that just hangs out. It's not going away.
It's not thinning out like it should.
Not nearly as much. And the H3OK framework predicts this. It calls it the void hydrogen floor. Remember that state transition we talked about?
The condensation.
Right. The conditions in deep voids, weak ionization, extreme cold, low density, they're the perfect recipe for realizing neutral hydrogen from that S energy. The framework argues that the voids are actually regenerating hydrogen.
So it's not just surviving hydrogen from the Big Bang, it's new hydrogen.
Exactly. The void effectively maintains a minimum density. It hits a floor that it can't drop below because the vacuum itself keeps replenishing the supply.
That is a wild concept. It means the universe is actively refreshing itself in the empty spaces.
It's not just a dying explosion.
I want to pivot now to the other side of the spectrum. We've talked about the empty voids. Let's talk about the heavy stuff, because the notes mention a crisis involving the James Webb Space Telescope.
Yes. The little red dots.
This has been all over the science news. For anyone listening who hasn't tracked this, what are the little red dots and why are they causing such a panic?
To get the panic, you have to get the bottom-up story we've been telling ourselves for decades. The standard story says the universe started as a smooth, hot soup of particles.
The Lego bricks.
Right. And gravity is the hands that slowly build the castle. But gravity is slow. It takes billions of years to pull dust into stars, stars into galaxies, and galaxies into giant clusters.
Makes sense. You can't build a skyscraper in a day. You have to lay the foundation, build the frame.
But then JWST looked back in time. It looked at redshifts, approx 13T3. That's only about 300 to 400 million years after the theoretical Big Bang. And it found monsters.
Massive galaxies.
Massive, mature galaxies. The sources cite JDSAS-GC Thruis-16-0 as a prime example. These aren't baby galaxies. They have supermassive black holes. They look like they've been around for billions of years, but they only had a few 100 million to form.
So the skyscraper is there, fully built, but the construction crew hasn't even had time to drive to the site yet.
That's it, exactly. The standard model math just breaks. You cannot stack the Lego bricks fast enough to get objects that big that early.
And this is where the H3OK framework comes in with top-down formation.
Yes. The framework introduces a concept called the projection codex. It argues that when the universe is projected from that fifth dimension, it doesn't start with dust. It starts with geometry. It starts with structure.
The notes mention primordial anchors. That sounds incredibly heavy metal.
It acts heavy metal. That theory posits that giant black holes were the first structures. They formed at time zero.
Wait, hold on. Usually, a black hole is a dead star. A star lives, explodes, collapses. You're saying these didn't come from stars.
Correct. The papers call them geometric condensations. They are the anchors. Imagine putting up the steel beams of a building before you add the walls or anything else.
So the black holes are the scaffolding.
And because that heavy scaffolding was there from day one, matter had somewhere to go immediately. It drained into these anchors, creating the first galaxies incredibly fast.
That explains the little red dots. They aren't anomalies, they're the foundation.
It totally reframes the data. The standard model looks at those massive early galaxies and says, impossible. This framework says, necessary. You need those anchors to define the shape of the universe.
This also connects to that patchy reionization point in the notes, doesn't it? The idea that the universe didn't just turn its lights on all at once.
Yes, this is the Lyman alpha evidence. JWST sees that the universe ionized it, heated up in pockets. It wasn't a uniform dawn. In this top-down model, that makes perfect sense.
Because the regions around the big anchors would light up first?
Exactly, while the voids, the spaces between them, stayed cold and neutral.
Which brings us back to the hydrogen. The voids stay cold, so they keep making hydrogen. The anchors get hot, so they build galaxies. It's a unified system.
It connects the very small, the hydrogen atoms, with the very large, the supermassive black holes, through a single geometric mechanism.
There is one massive elephant in the room, though. If we're rewriting the beginning, if we're saying no Big Bang explosion but a projection, why is the universe hot?
The cosmic microwave background.
Right. The CMB, that faint glow of radiation everywhere, that's the smoking gun for the Big Bang fireball. It's the afterglow. If you take away the fireball, how do you explain the heat?
The H3OK framework proposes a cold start.
A cold start, that sounds chilly.
It is. The claim is the universe began at zero entropy and zero temperature.
Okay, but we see the heat, we measure it. It's 2.7 Kelvin everywhere. Where did it come from if not an explosion?
Gravity, specifically those primordial anchors. Imagine the moment those massive geometric anchors formed. The gravitational collapse involved is, well, it's unfathomable. When you compress matter that hard, that fast, you generate heat.
So instead of one giant bomb going off everywhere,
It's millions of localized furnaces turning on at once. The notes describe the CMB not as the echo of a single creation event, but as the integrated result of all these distributed heat sources.
I like the analogy of radiators. The Big Bang is like setting the house on fire to warm it up. The cold start is like turning on a radiator in every single room at the same time.
That's a great comparison. Over billions of years, that heat scatters and homogenizes. To our telescopes today, it just looks like a uniform background glow. But the origin isn't an explosion. It's thermodynamic work performed by gravity.
It changes the narrative from the universe is cooling down from a fire to the universe warmed itself up through work.
And that distinction is crucial because it supports the idea of the universe as an open system.
Explain that term. Open system versus closed system. This seems to be the philosophical core of this whole thing.
The standard model treats the universe like a closed box. It started with a set amount of energy, the battery was fully charged at the Big Bang, and it's just slowly running down. Entropy increases. Heat death.
Cheerful, we're just waiting for the battery to die.
But the S-matter framework says, no, the box is open. It's connected to that fifth dimensional source. It's not running on a battery. It's plugged into the wall.
It's being continuously fed.
Continuously instantiated. The rules of physics, what the source calls the projection codex, are fixed. But the realization of matter is dynamic. We aren't just drifting in the debris of a past explosion. We are part of a continuous creation process.
This is a lot to take in. We've gone from, is the universe leaking, to the universe is a projection from a higher dimension anchored by primordial black holes.
It is a heavy lift. It challenges our most basic assumptions. But look at what it solves. It solves the expansion rate tension. It solves the impossible early galaxies from JWST. It explains the hydrogen in voids. And it does it without inventing invisible magic like dark energy.
It replaces the magic with geometry.
Geometric mechanics. It suggests that if we want to understand the universe, we need to stop looking for new particles to fix our equations and start looking at the very structure of space itself.
So, for you listening right now, maybe driving home, looking up at the night sky, what's the takeaway? How should you look at the stars differently tonight?
I would say, look at the darkness.
Mhm.
We naturally focus on the stars, the light. We think that's where the action is. But if this framework is right, the real action is in the voids.
The empty spaces.
That is the engine room. That is where space is being created. That's where matter is transitioning into existence. The stars are just the anchors holding the structure up, but the voids are where the universe is actually living and growing.
That's a beautiful thought. The darkness isn't empty, it's just the part of the canvas that's being painted right now.
Precisely.
This has been a massive shift in perspective. From leaky buckets to fifth-dimensional projectors, it's dense, but honestly, it feels more elegant than just boom, it was an accident.
It offers a cause. Expansion isn't an accident. It's a requirement for time to exist. That is a deeply satisfying concept.
I am definitely going to be thinking about primordial anchors all week. And next time I see a JWST image with those little red dots, I'll know they aren't bugs in the simulation. They're the features.
There's a foundation.
Thank you for guiding us through this deep dive. And to you listening, thanks for being part of the conversation. Keep looking up and don't ignore the dark spots. That's where the magic, or rather the mechanics, is happening. We'll see you on the next deep dive.